With the release of the Android M Developer Preview SDK, developers are jumping in to make sure their apps are up to date with changes in the framework. I'm Wojtek Kaliciński, and I'll show you how new features that we're introducing in Android Studio 1.3 can help you with the transition. The single biggest change in Android M is the overhaul of the permissions system. From now on, before using certain APIs, you need to make sure your app asks for the necessary permissions during runtime. But given a large code base, how do you know which methods actually require this special handling? In Android Studio 1.3, we're adding a lint rule that detects methods marked with the new requires permissions annotation from the support library. The editor will now highlight code that uses permissions which are missing from your Android manifest. Moreover, if it detects you haven't performed the necessary runtime check in your code, it will suggest a quick fix. Static code analysis like this can help you catch common programming mistakes even before you run your app on the device or emulator. The requires permission annotation is actually defined in the support library and works in tandem with the lint checker in Android Studio. Let's go through some other annotations that you will find in the latest release. Threading annotations guard you against calling methods on the wrong thread. Let's say you're doing some background processing, like in this async task example. Because the async task methods are already properly annotated, the IDE will alert you if you try changing the UI from here by calling methods on the TextView instance. On the other hand, Android Studio knows it's safe to invoke UI code in onPostExecute, as it is marked with the main thread annotation. Up next, the size and range annotations for integers and floats. They can be used for controlling the length of your arrays and strings, or making sure a number is in a specified range. They're especially handy for annotating method parameters, so that the caller can immediately know what kind of values are expected. If you want to study those in more detail, as well as learn about other annotations like checkResult and callSuper, click through to the documentation here. Remember that you don't have to rely on the annotations that we've included in the Android framework. You are free to add them to your own methods and classes so that anyone using your code will benefit from the additional checks performed by Android Studio. Speaking of sharing code, Android Studio 1.3 introduces support for hiding resources in library modules. Perhaps it's easiest to demonstrate on an example. Here's what used to happen when you tried to use autocompletion in a layout file when you have AppCompat in your dependencies. And here is the same operation using the newest versions of both Studio and the support library. Most of the resources we see on the left are used internally by the creators of the library and were never meant to be available for third-party developers. Not only do they introduce clutter and pollute your project's namespace, things might also break with any update if you decide to use them in your layouts. To define which resources should be visible for users of your library, simply put a public XML file in your values folder. Provide an entry containing the type and name of each resource you want to set as public. This information will also be bundled and available to Android Studio if you decide to distribute your library in AAR format. With the release of 1.3, we're bringing more tools that were previously available as external applications into Android Studio. You can now open your object allocation trace files in the new allocation tracker, which shows you a visual overview of where allocations happen in your code and gives you a way to dig right into the data. Another memory inspection tool that is now available right in the IDE is the Heap Dump Viewer for opening HProf files. It gives you access to the reference tree of any object in memory, as well as a property inspector, similar to the variable debugger window. Use it to examine the state of objects at the moment when the memory snapshot was taken, and to track down any rogue references that prevent them from being garbage collected. By the way, we've also added small improvements in the traditional debugger interface. From now on, when you inspect a variable that holds a resource identifier, you can easily see the human-readable name instead by switching to the Android typed integer view. There are many more new features in Android Studio 1.3. Integration with the data binding library, adding developer services from the project structure dialog, live code templates, and finally, a preview of the upcoming C++ editing and NDK support in the IDE. So upgrade Android Studio now, and as always, please report any bugs in our Google+ community here. Thanks.